In this video, we're going to be talking about what happens when you have a different number of neutrons. So many elements have atoms with different number of neutrons, and these are called isotopes. For example, we have carbon here, which you can see by the pictures that we have. We have the same number of protons in each. There's 6 of the orange little balls. And the same number of electrons, we have 6 electrons around the outside, but the difference is that we have different number of neutrons, which overall changes the mass of each of these atoms, so they're not exactly the same. Another way to write this is, let's try that again. Another way to write that is putting the symbol, and then in the top as a superscript, you put the mass number. So you could write carbon-13 or 13C. So let's go down and look a little bit more into isotopes, looking specifically at hydrogen. So we have hydrogen here. We also have deuterium, which is where you have a mass of 2, and tritium, which you have a mass of 3. Most atoms don't have special names for their isotopes. This one's just special because it has a lot of different uses, and they react pretty differently in more complex cases. But let's look at how these differ. So hydrogen has 1 proton. That does not look like a 1. Let's try that again. 1 proton. And to define hydrogen, we have to have 1 proton throughout. So all of these, as you can see, have 1 proton in the nucleus. Then we need to count our number of electrons. Hydrogen has number of neutrons. Hydrogen has 0 neutrons. Deuterium, we see the green ball, we have 1. And in tritium, we have 2. And then lastly, we have our number of electrons. If we count them, we have 1 across the board again. Those are in red. Okay, and so now let's look at our mass number. So our mass number is when you add together our protons and neutrons. So for hydrogen, it is 1. Deuterium, it would be 2. And tritium, it would be 3. Again, because we're adding together these 2 numbers. And then lastly, what is our atomic number? So for all cases, it's going to be your atomic number is defined by how many protons you have. So we have 1 in each. So that's our atomic number across the board. All of these are the same atom. They're just isotopes of that atom. So what's important to notice is that we have only a couple of these rows are actually going to be changing. So protons stay the same, but what changes are the number of neutrons. And then additionally, because the number of neutrons changes, our mass number changes. So we have a question down here. How do we know which isotope is the most abundant? So what we would do is we would go to the mass on the periodic table, which tells us a number with a decimal. Whatever the closest integer to that number is going to be the most abundant isotope. So that's where this video is going to end for you guys. I will see you on the next one.